Alright, objective 1, problem 1 has Fe and S and H and Cl reacting to form FeCl2 and H2S. You see that there's 4 elements in the reactant side, and you look at double replacement, it's AB plus CD, which is 4 elements, yields AD plus CB, which would be 2 new compounds. So then you see that FeS plus 2HCl yields FeCl2 and H2S is a double replacement. Alright, for problem 2 on objective 1, you have Fe and CuNO3 yields FeNO3 plus 2Cu. The Cu is getting displaced and Fe is taking its place, so that you know that's single replacement. If you look at number 3 on your reference sheet under single replacement, it's the metal-metal replacement. For number 3, you have a metallic nitrate in NaNO3 yields NaNO2 plus O2. So anytime you see that O2 on the side, you know that's decomp, and you see that the element is losing an oxygen. So NaNO3 decomposes into NaNO2 plus O2. And then for problem 4, you have the formation of a binary compound in Al2S3 from 2 individual elements, so you know right off the bat that this is synthesis, because if you look on your reference sheet, the formation of a binary compound is only under synthesis. As I said before, if you see the O2 on the product side, it's decomp, but if you see the O2 on the reactant side, then you know it's combustion, because if it's an element with 2 nonmetals combining with oxygen to form CO2 and H2O, you see CO2 and H2O on the product side, then you know that's also a sign of combustion.
Alright, for number 6, you're working with aluminum and oxygen. So you start with 2 aluminum and 3 oxygen, and you have in the products 1 aluminum and 2 oxygen. So you're going to add a 2 to the aluminum oxide, and then a 4 to the product aluminum, and 3 to the product oxygen to have them balanced. Alright, for number 7, you're going to start off with 1 calcium, 2 sodium, 1 sulfate, and 2 chlorine. And then on the product side, you're going to have 1 calcium, 1 sodium, 1 sulfate, and 1 chlorine. And so you need to double sodium and chloride. So you would have 1 sodium sulfate plus 1 calcium chloride yields 1 calcium sulfate plus 2 sodium chloride. Alright, for problem 8, you're going to start off with 1 calcium, 2 hydrogen, and 1 oxygen. And on the product side, you have 1 calcium, 4 hydrogen, and 2 oxygen. So what you want to do is double the water, and then you will be even. Alright, for number 9, you have 1 carbon, 4 hydrogen, and 4 oxygen on the reactant side. And then on the product side, you have 1 carbon, 2 hydrogen, 3 oxide. So what you want to do is double the oxygen on the reactant side and double the water on the product side, and you have 1 carbon, 4 hydrogen, 4 oxygen on the reactant side, 1 carbon, 4 hydrogen, and 4 oxygen on the reactant side. Product side.
Alright, so in objective 2, problem 1, the thing you need to do is pick out the keywords in the problem. So as you see for number 1, it says a solid piece of magnesium, so you know to write MgS for solid, and then nitrogen gas, so you know how to write N and then G, yields Mg3N2 because that's magnesium nitride, and it does not give you a state symbol for that one, so it's just MgS plus N gas yields Mg3N2. Again, picking out the keywords in problem 2, you have potassium chloride or chlorate, no state symbol, so it's KClO3. When heated, decomposes to potassium chloride and oxygen gas. So you have KCl with no state symbol, assuming it is aqueous, and then you have oxygen gas, so O2G, and then you balance it, knowing that you need to double the KCl and triple the oxygen because you need to put a 2 in front of the KClO3 to make everything even. And picking out the keywords in number 3, it says zinc metal, so Zn solid, plus CuNO3 aqueous because it says a solution of copper 2 nitrate, and then produces a solution of zinc nitrate and copper metal. So then you know you have Cu solid and then ZnNO3 aqueous. And so your final equation reads Zn parentheses solid plus CuNO3 aqueous because you have to balance out the copper 2 nitrate yields ZnNO3 plus Cu solid.
All right, in step 4, you're going to have zinc and copper sulfate mix, and that's going to create zinc sulfate and copper. And what you want to do is look on the activity series chart and see like the reactivity of the metals. And we're going to look to see if zinc can replace copper, and it can on the chart, so the reaction will go to completion. All right, for number 5, you're working with iron reacting with water at room temperature. And you're going to look on your activity series, and you're going to see that iron cannot replace hydrogen, so there's going to be no reaction. And problem number 6, you have an iodine gas is bubbled into a solution of magnesium chloride. And so what you want to do is check on the activity series of halogens to see if iodine can replace chlorine, and it cannot, so you're going to have no reaction.
For this section, if you look at your honors chemistry reference sheet, it basically tells you how to do this. So if you know that Al plus HCl is a single replacement by looking at your reference sheet and seeing it under single replacement, you should know your products. It gives you the guide for how to predict the products. So Al plus HCl is going to be a single replacement, so the Al is going to replace the Cl. And then, the Al is going to replace the H. So then it becomes 3H2 and then 2AlCl3 once you balance it are the products. Again, looking at your reference sheet for number 8, you see the metal oxide and then the water. So you look under that, and that is synthesis involving the water and the metal oxide. And it's going to yield a metal hydroxide, which means in this case it's going to be NaOH because you have NaO. And then it forms with H2O, and then there's an OH that is also included in the products. But you leave that out because it's not important. So your final equation reads NaO plus H2O yields NaOH. Anytime you see a carbonate involving a metal that's an ionic compound, and then you just see the yield sign, you know that's going to be decomp because it's one element. So you take out the O2 from CO3, and that leaves you with just O, and then you have CaO plus CO2 because you're combining the C with O2. So whenever you have decomp, it's going to produce CO2, and then a metal oxide. So CaCO3 yields CaO plus CO2.
Alright, for problem 1, you have NH4 and that is soluble because it has ammonium in it, and ammonium is always soluble. Barium carbonate in question 2 is insoluble because all carbonates are insoluble.
In determining the precipitate, you only have to look at your solubility rules, and for number 3 and 4, you only have to know one solubility rule. So when you look at number 3, one of the products is a nitrate, and when you look at number 4, one of the products is a nitrate. And nitrates will always be soluble. So for number 3, Ba3PO42 is going to be your precipitate because that's going to be insoluble. And then for number 4, PbI2 is insoluble. But all you have to know is that nitrates are soluble, and those are never going to be your precipitates.
Alright, for problem number 5, you're going to have magnesium nitrate plus sodium carbonate yields magnesium carbonate plus sodium nitrate. And the precipitate is magnesium carbonate because magnesium carbonate, the carbonate is always insoluble. Alright, for number 7, the correct answer is sodium chloride because chlorides are soluble except lead, silver, and mercury, and you want to create a precipitate, so you want to use chloride.
Alright, some of the positive lab tests we've learned about in honors chemistry are holding the glowing splint and gas to determine if there's oxygen, and holding the lighted splint and gas to determine if there's hydrogen. So you look at number 8 and 9, and in number 8, oxygen is one of the products, and in number 9, hydrogen is one of the products. So those are the tests to determine if those two are present. The glowing splint for oxygen and the lighted splint for hydrogen. If the light splint goes out, there's hydrogen present, and if the glowing splint lights, then there's oxygen present.
So for problem number 1, you have potassium iodine plus silver nitrate yields potassium nitrate plus a solid silver iodide. And the balanced complete ionic reaction is potassium aqueous plus iodine aqueous plus silver aqueous plus nitrate aqueous yields potassium aqueous plus nitrate aqueous plus silver iodine solid. And then the balanced net ionic reaction would be silver aqueous plus iodine aqueous equals silver iodine solid. Alright, for problem number 2, you have lithium sulfate plus calcium nitrate yields calcium sulfate plus lithium nitrate. And the balanced complete ionic would be 2 lithium aqueous plus sulfate plus calcium 2 aqueous plus 2 nitrate aqueous yields 2 lithium aqueous plus nitrate aqueous plus calcium sulfate solid. And then with the balanced net ionic, you're going to cancel out anything that doesn't work. So it'd be calcium plus 2 aqueous plus sulfate minus 2 aqueous yields calcium sulfate solid. All right, for number 3, the 2 indicators can be anything in the acronym GOPEC, which stands for change of gas, odor, precipitate, energy, or color.
For this neutralization reaction in problem 1 on objective 4, which is technically problem 4, you just basically look at it as a double replacement reaction. So you have H2SO4, so hydrogen, and then sulfate are your 2 elements there. Then you have LiOH, so then the hydroxide and the lithium are your 2 elements there. And then so you go ABCD equals ADBC. So your B and C are Li and SO4, so it forms Li2SO4. And then your H and your OH are your A and D, so it forms AD, which would be H2O. And so your final equation reads H2SO4 plus LiOH yields H2O plus Li2SO4. And you are done with your practice test.